Hello everyone, welcome to this particular podcast. So this is the new podcast series that I have decided to start, which is specially for the research and the PhD scholar in the field of AI and ML. And today in particular we have the new guest. The first guest that I decided to choose is Sohan Nag, who have worked in the field of geology, who have done his BS and MS integrated in the field of geology, and he also used the AI and ML tools in his research as well. So, Sohan, would you like to introduce about yourself?
Yeah. Hello, everyone. I am Sohan Nag, and I have done my master's, as he has said, from Indian Institute of Science Education Research, Bhopal. I particularly done my research on the field of remote sensing and fluvial geomorphology, which we're going to talk about it later. My degree is on geology, so I am by degree I am a geologist, but my preliminary work or primary work that I had done is in machine learning and remote sensing. So it's glad to be here. It's glad to be the first person to have to be a guest in the podcast series. So yeah, uh, let's chat about all the things that I know that I might not know. So yeah.
It's really nice to have you, Sohan, as our first guest, and it's really great that we're gonna have this conversation. And you mentioned that you are not a geologist. Can you tell us a bit about yourself? Like, what does it mean to be a geologist, and why you don't call yourself a geologist?
Okay, so a geologist, in terms that you okay. So first of all, we have to understand what is the field of geology or the geologists do. The geologists are primarily, you know, responsible to understand our planet uh, from the lens of science. So it's a geological science that we study. It's similar to geography that you can say, but it's not that similar. It's not that similar. There are certain theories, certain rules, and certain just like any other applied science is there out there. Then the geology or the geological science field is literally a field of that applied science. So basically a geologist applies those rules or those theories and try to understand that how our earth has formed, how its dynamic nature, is ever changing nature is working, and to understand and to predict what will happen in the next. So from studying the past we can better predict our future. That's the like main gist of earth science or geological sciences. So yeah. So in lieu of that, you can say definitely you can say that machine learning and artificial intelligence will gonna help us, that we'll talk about later. But still, um, yeah, to say that like who is a geologist? Well, these people are geologists who really try to understand our planet, not only our planet but also outside planet as well. I mean, if you wanted to go to Mars, then you have to study the Mars. Then you have to study the geology of the Mars, or the climate of the Mars, or the dynamic processes that is happening on the surface of the Mars. So how do you understand? Well, you understand the Earth itself, and then you try to understand the other planets itself. So yeah, so we are some kind of observer, some kind of you know like uh, trying to understand our planet, trying to understand our surroundings, our nature. So yeah, this is the field of geology. I don't call myself as a geologist because the geologist does this every day in and out. I don't. Not now, at least. So that's why I don't call myself as a geologist, but I can, pretty much everyone who is interested in geology and have a at least a certain amount of knowledge or expertise in the field of that in the field of geology, well, they can call him themselves geologists. So yeah, there is no no put it, no there is no stop there is no stoppage that anyone uh, cannot say that he's or she is a geologist. So yeah.
So the title geologist, according to you, is subjective, right? So according to you, who deserve the title as geologist? And Like, do he needs to have a PhD on it or master on it? He needs to work on some certain kind of thing or have certain kind of curiosity from the childhood or something like who actually deserve the title geologist, or it's actually the subjective, like the word geologist means different to every single individual.
uh, uh, so to answer the question that you have raised, right? So who should call themselves a geologist? Well, to be honest, I don't know. I mean, people people will gonna call themselves as a geologist if they have, like I said, that if they has a certain expertise on the field of geology or the field of earth science or geological sciences, and have certain expertise, have done some good work, they can call themselves as geologists who are working day in day out to understand in the field of in our nature, and how our planet has formed, and how it is ever changing. Like I said, right, it's it's the people who have some expertise on the field, right? And that's why they can call themselves as a geologist. But people don't call themselves as geologists. People really like to call themselves as a observer, as a researcher, uh, in the field of any kind of science. You cannot call anyone as a physicist, right? uh, they has to have certain kind of expertise in the physics, and they don't call themselves as a physicist. They don't introduce themselves as a physicist, right? So yeah, it's like that. So they can call themselves like a researcher, or trying to understand the field of physics, or in a person who is trying to understand the field of physics. So yeah, it's like that. I don't know, people is gonna tell someone that yeah, I can call himself as a geologist because he has done some work. But as an individual, a student, or as a researcher, they don't call themselves a geologist in that way. So yeah.
That was interesting point too. Uh, I never actually thought it that way. And the example you gave as a physicist, I also never actually thought about that. That that's not how people give themselves a title. So that was something new. So tell me, like, tell me about your childhood. Like, where you have you always been interested in geology? Like, how does a child who's a student or who's in school, how do they generally get interested in geology? Like, do they love to explore the rocks, love to explore the nature, love to explore the geography? Like, how? Tell me about your school life and were you how like were you interested in science and mathematics for beginning, or it was a late realization for you that you wanted to get in this field of geology?
Hmm. Well, okay. So let address the first question, like how I get into that field. Well, to be honest, in a country like India, there is no such boards that I have heard of who introduce the field of earth science or geological sciences to a kid. At least that was not present when I was growing up. So there's that. How I came, so how people people who is going to have an interest in the field, they don't, they won't gonna have a interest in the field as of then. So how I got into that? Well, to be honest, let me share my childhood first. So I am interested in science. I am interested in physics, particularly in planetary science, astronomical sciences, so on and so forth. As usual, people with high interest in physics or high interest in maths will have a high interest in these types of topics as well. So in that way, I was introduced to the planets itself, in my childhood. I guess it is around class 5 or 6 maybe. So I was interested on that, and by the time I turned class 9th or 10th, uh, so my interest grew into pursuing science. I was very much interested, and after I joined my college, I was introduced to the first class of geology, which is the introduction of the Earth and environmental science. uh, and then what happened is that, um, Well, after that, um, uh, I I was. Can you hold for a second? Okay, can you hold for a thing that I was talking about, right? Sorry about that interruption. Sorry.
Yeah, it's fine.
So, well, um, then what happened is that I was interested in the geology, not in the first time, but uh, it took some time to grow up on me. But then again, I when I delve into the advanced topics as well, then I understand that okay, that this is a very good science, which I really so basically I wanted to understand the planet system, or the how the planet has formed, or how the dynamic process is happening, all of those things, right? And and I understood that this field, this geological science or the earth and environmental sciences, is something that is actively working to understanding the science, understanding our planets and the other terrestrial planets as well. And therefore the interest has been much more from that point of time. So yeah, and that's when I started actively pursuing the field, and understanding the field.
From this, I got curious about one thing. You mentioned the planets as well, right? So, what's the connection between geology, astronomy, astrophysics, and space? Like, is it true that the people who got interested in geology, they might have interested in space and astronomy as well, and likewise the other way around? But I never thought geology could be used in space and astronomy as well, since I have lack of knowledge in that. So, could you share some insight on that? Like, do geologist and astronomy goes together, and do both of the astronomy people and geological people both in have research work together, or could be curious about both of their research and both of the field interchangeably?
Hmm. Okay, so the field of astronomy deals with the star system, right? How stars are formed, how from the stars the planets had formed, or some like the astronomy field is dealing with various kinds of topics, which I don't really know about. But the thing is that when I was introduced to the that some of the science books which talks about the astronomy, like have you ever heard of some books that shows the planets, star systems, how does that forms. So there are some distinctions of terrestrial planets and gaseous planets, right? The terrestrial planets are being the first four planets up to Mars, and the gaseous planets are the Jupiter and Saturn and so on and so forth, right? So the terrestrial planets, right, and the programs that are happening, that were happening in the Discovery Channel or something like some science channels and all. So they are also showcasing the how the Mars has really looks like, or how you know the Venus really looks like, and so and so forth. Is there any life on planet Mars or some other planets which might have a condition of having life? So that is really in the parallel topic of astronomical science and planetary science, right? The planetary science also deals with the formation of the planets, how the dynamic process is happening, how the climate is happening, what will be the cause of have like let's take an example of Mars. Like Mars, we say that Mars might have a good water system, like fluvial system, right? But it doesn't have it right now. And why is the reason? Because there are some reasons, right? And to understand that, either you will understand from the point of view of planetary science field, or either you will understand from the earth and environmental science field, because earth is also has seen some of these changes, where there is a water flowing, but then after some time it is not. And guess what, where it's happening? It's happening in the desert, where at a certain point of time the water flows, and then the other point it is dry. So So maybe you can understood the desert and how this happens, and try to understand that how the pluvial system on Mars that has been dried up. So in that way it is interlinked. It is not explicitly connected, but it is interchangeably connected. Yeah, it is connected from the various topics and from the various perspectives as well. So yeah.
That's fascinating. So tell me about your first experience in geology. Like when did you decide that you wanna pursue geology as your career? Like what was your first experience? Like any first project you do, any maybe project in the school or anything that you explored in the field that made you decided that this is the field that I wanna build my future in.
No.
There was
Okay.
no like
Well, that I have said, right?
there
Yeah.
was no
So
single incident.
I have said earlier that no, not a single incident. It took some time that I, like I said, after having the first class in my first year of college, as an elective course, obviously, it was given as an elective course. I took it. I liked it little bit, but I didn't think explicitly to pursue the field. Then again, we have to take some other 3 or 4 courses on that, and through that process, I understood that I am very much interested in the field of archaeology or earth and mineral sciences, and yeah, and that's where I came into the field, and I thought that I would pursue the field. Yeah.
All right. So tell me about the BSMS integrated program that you have done. What made you decided that you're gonna
Hmm.
choose this degree, and how was your experience in the degree, and how does this program differ from every other degree in the India?
Hmm. 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 So, okay. So in India, it's typically expected to have a 3 years of bachelor's course and then 2 years of master's course, right? Uh, and the integrated BSMS course offered by the ISER or similar kind of institutions is such that you will have 4 years of bachelor's course, 1 years of master's course, okay, and that way it is integrated. So in particularly in ISER Bhopal, the course is divided into pre-major courses and then major courses. So pre-major courses will take up 2 years, and then major courses will take up 2 years. And in that way, it is an integrated course, and then 1 year of research work, and that's how you done the BSMS course. It's every other courses, which is like BA physics, chemistry, maths, bio, and earth and environmental sciences and all those things. So how it differs? Uh, well, to be honest, the BSMS course deals with the vastness of the field itself, where in a typical BS course of geology or earth science, offered by many of the very good institutions like Hyderabad University and all these places, um, deals with the depth of the proper geology as well, and in that way it is different. So the vastness of the course is much more, because we are taught uh, you know because we are also focused um, in the in the interdisciplinary science or interdisciplinary research, such that we have to understand all the other fields, associated fields, and that's why it is vast. It is not in the going to the depth. Students are expected to do their own study, if they wanted to go in a particular field in depth. And the course is nice. The course is really nice. It is really in the parallel to the other courses that is offered by other foreign universities as well, which also deals with the interdisciplinary research and all. uh, but yeah, in that way it is different from the normal not normal and the regular BS geology courses that is offered in the India.
All right. So tell me about your experience studying geology in this course. Let's say you got interested in geology for the various reasons that you have mentioned in this podcast, and after getting into the course, like you might have some kind of expectation that I might learn this, I might explore this, but does this education system ever discourage you that after getting into the course, like it's really different than how the geology being pursued in the real world? Does it ever happen to you? How was your experience in this course compared to the real world geology?
Hmm, hmm. So, okay. So, geology itself is a applied science, right? Geological science is an applied science. And that being said, the course has to have some kind of real world applications, and should prepare for the real world life, right? Real world applications as well, real world skills, right? So the course is nice in that sense. The course really does emphasize on the real world applications as well, the labs, the field works, which are really good. uh, was in the parallel to the real world applications as well. So we have a very good field works, where we go outside, try to understand how a proper geologist would understand or proper researcher would understand, and in that way it is skillful enough. And the well, if you wanted to say that people are working on the remote sensing or GIS stuff and all those things, that is also happened, that the lab is good. So the lab courses is also good. It's a mix of both lab and the theory courses in our BSMS course. So you are pretty much well equipped theoretically and experimentally, in the to survive or to thrive in the real world.
Right. Was there anything about the course that disappointed you? Is there anything about the course?
Uh, only thing that that the pre-major in the pre-major, people should have a little bit of more geology,
Hmm.
such that the introductory topics can be covered there, and the advanced or in-depth topics should be covered in the masters or the next 2 years. The first 2 years should be the introductory topics, which is there. I mean, it's not that it's not there, which is there, but I believe that it should be more. It should be more, because the program, what it says, that in the pre-major you have to take the major subject that you are going to have in your masters or the in the later years, and then two additional subjects that you have to take, which you wanted to pursue. Like, you can take geology as a major course, and then you have to take other two subjects like maths or physics or chemistry or biology, or maths or biology, or physics and biology, something like that. So even you can take social sciences or social studies. So there is no stopping on that. So uh, so people should have a little bit more of a geology than taking other two subjects. Like, get rid of one subject, add more geology introductory topics, and then delve into the depth of such topics or such courses. Like, in our ISER, the paleontology, which is the excavation of dinosaurs and other prehistoric animals and life forms. The paleontology is a very nice course to have, but you can't have it. You won't have it because the course is not there. Now, if they can introduce some other exciting courses in the field of geology or in the field of earth and environmental sciences, then it will be much more good. Or going into the depth of geophysics, like properly, uh, properly having a geophysics related, or the geophysics in-depth or advanced courses, that would be a good addition to the program. But overall, it's good. Overall,
So,
it's good.
so if I'm correct, you have complained about the curriculum, right?
Can you repeat the question?
Yeah. So I asked, like, if I'm correct, you have complained about the curriculum of the course, right?
No, not a complaint. It's not a complaint. It's a suggestion.
Suggestion.
We also have suggest these things when we are there. If the department has told us that yes, we will also think about it. Uh, so the reforms has been done. So some of the reforms has been done. Some of them are not. Well, probably we'll have to look into the future to have a good courses. It has the potential. I would say one thing. It has the potential to be one of the best earth and environmental science course in the India, because the faculties are good. Faculties are really great. uh, their research is great. Their teaching is also nice, and the courses are there, but there are some minor additions that can be done to make it really more great. So yeah.
So you can say that it's better than most of the course out there in India, because most of the course always has the outdated curriculum, the outdated activities, the assignment and the workload they give like is utterly useless. So the course that you have mentioned and the said about your course, it seems like better than every other every other major course in the India, like especially all the campus course and
No, no. I have said that it has the potential to be a much more greater option. I didn't say that it's a you know it's better than any other courses, because the course doesn't make the course great. Let me be clear on that. Why I say the course doesn't make the course great, the teaching does. The teacher, the curriculum does. And in that way, there are colleges which are doing great. uh, we are also doing great, but I believe there are some things that can be done, that has to be done to even make a greater point, or even make a greater course, right? So yeah.
that was the point that I said is from myself, said is my personal opinion, and
Yeah. But the nuances has to be there. See, I understood that it's easy to simplify everything, but then it lose the nuance, and the nuance has to be there. If you are talking about the education field, the, every time you talk about some course or some another course, you have to have some nuances there. Like take an example which I mostly see on the internet. Okay. People do sell the courses of Next.js, or the web3 development course, or roadmap, or something like that. Every other people who has done their work, or who has made their courses popular, has something to offer. You cannot say that this course, this some particular person's course is better than other person's course, because the nuances will be lost in that comparison. And that's why I'm saying that you have to understand the nuances. And that's why the answer is quite long. It's you cannot simplify by saying that people it's much more better than other geology courses in the India. No, it's not that. I just said that it is a good course. It is a great course, but it can be much more than that, if there are some things that can be changed, which was proposed when I was there, when I was leaving, that in some meetings, these are proposed. I don't know what has happened after that, but yeah, these are the things that has been proposed every time. I mean, yeah.
And to that, I would like to add that the course is good when you balance the teaching and the course itself. Not just because one thing can't be good. If just a course is good and teaching isn't good, then it won't be a big good deal. And if the teaching is good and the course is outdated, no matter how teaching is good, but if the course is useless, if the curriculum is useless, the chapter is something that you will be use it on 1990s and not gonna be in practical use in this current day and age, then that won't be useful either. And when you said that it's not like it's better than every other geology course, I didn't mean it particular to be geology. I mean like every other course that been taught, especially if I take example on the engineering, like they make the student waste time on the useless assignment, writing thousands and two thousands of page, just copy pasting from the textbook and just writing it out on pen and paper on the 5 pages. So that's something I felt that your degree have upgraded on. Like they are actually, I think that they are actually helping students to learn about geological from the practical use instead of just the traditional education system out there. So that was the point I was trying to make. How that's that's the reason I
Hmm.
said my opinion how it's better than every other major courses in the Indian that follows the traditional Indian education system.
I understood your points. Well, in the engineering courses itself, it is really, really sad to see that the courses are in the most of the in engineering colleges are outdated in that sense. People do complain about that. People do really complain about that. But this is up to the you know the faculty members or the person who made the courses on these universities or the engineering colleges itself. But yeah, it is such that the education system needs a reform on that perspective, I guess. We are lucky to have a course or to have a field where these are not not the majority of the problem. Yeah, there are some problems, but not the majority of the problems, because it's a field based course and you have to have certain understanding of using softwares, and as well as using hard coded pen on pencil. If you don't have any software, like, okay, let me share you one thing, one example that you will understand why it is important in our field of geology to have pen and pencil even in a today's day and age. We use something called a GPS, or global positioning system, right? To navigate in the field itself, in the remote areas as well as uh, in the field, right? So what if the GPS machine that you are using is not working? What will do? You have to use your compass, you have to use your pen and pencil to really understand the topology or the the surrounding, and to understand where you are right now in a physical map. So you are going to use those pen and paper and the physical things to understand. It is much more easier to work with the machines, it is much more easier to work with the softwares, but you have to have some kind of you know idea to if you get lost, or if you get uh, the machine is not working, the software is not working, then how are you gonna understand a bit? So you so in engineering, I don't think that it is not necessary to have a pen and paper. It's my opinion, it's completely my opinion, I might be wrong, but in the field of geology, it's still relevant to use pen and paper even in today's day and age. Not to so basically, okay, there is another example that I can give you. Okay, it's a quick example. So there are two rocks, right? One is big, one is small. How you gonna say that one is like one is big or one is not big by comparing the size? No. If you put a big rock in the distance, and you put a small rock in the close to your camera, they will gonna match the same size. People gonna believe that it's a same size rock, right? But then how you gonna understood that this is a small rock, this is a big rock? By putting a coin, or by putting a pencil, or by putting something that is everyday use, and you know that the size of that thing, what it can be. Like unused pencil, it will be around like 15 or 16 centimeter long, right? It's a small scale long. So you put a scale onto the next of the rock, or into the onto the body of the rock, and you understand that this rock is much more bigger than the scale or much more smaller than the scale. So you have to have some kind of idea, right? You can take a photograph, you will take a photograph of it, but how are you going to understand that? So these are the skills that people every day use in the field of geology, and that's why it is still relevant to use pen and paper or something like that. Even if your camera died, then how you gonna show that this is the rock bedding, like the beds of the rock are going this way or that way, or it's going in this direction. So how are you going to show that? By drawing with your pen and pencil. So in that sense, it is really needed to still have some skill around pen pencil and such and such, so and so forth. So yeah.
That's interesting. I didn't understand the part when you said mention about the camera and the pencil. Like, how does it connected? Is it the matter of perspective or is it the matter of distance and measurement? I didn't understand the connection.
Okay.
I
Okay,
understand the
so
drawing
it's
part.
a so in the planetary scale, I can give you an example. Okay, so sun and moon are different distance from the earth, right? But they appear on the same size, right? And moon is much more smaller than sun, right? Then how can you say that sun and moon are not like one is big or one is small? Because we can measure it. You can measure it, right? You can measure the how much time it takes to have a light or something like that. There are some mathematical equations that has been derived to understand the distance of sun and moon, right, from the earth. That is the similar kind of perspective that is used in the field of geology.
I
So
understand.
it's simple. It's
I understand that part. I didn't understand the
yeah,
connection between pen and pencil with this terminology, with this example that you gave.
yeah.
Like, I wasn't able to connect these two terms using pen and pencil and this example, the two example of rope and sun and moon that you gave. Like, where does the pen and pencil be used there?
For that reason, you have to go out with the field and really have to spend a day with the geologist. So yeah.
Right.
if you have some geologists in your surrounding, then you have to spend a day or spend a time some time together. Then you can really understand that how pen and pencil works in everyday field of geology. Yeah.
All right. All right. So let's move on now. So can you tell us about the
Yeah.
research you have done in your MS, like the thesis that you have said with me, the that you have wrote?
Hmm.
Can you tell us about it? Like, why does it matter to you, and what does the research actually talk about?
Hmm. So, okay. So, my master's thesis, which is titled Impact of Sand Mining in the Morphology of the Yamuna River, right? Yamuna River, which is
Yamunari.
in the north side of the Delhi, right? So, everybody knows Yamuna River. It flows through the Haryana and UP side. So, through the Delhi and get mixed with the Ganga, right? It's a tributary of Ganga, right? So, uh, well, okay. So the first thing is the impact of sand mining. That is that I have said, right? The impact of sand mining on the morphology of the Yamuna River, right? So what is the term called morphology? Morphology means the characteristics of the river, right? There are certain characteristics of the river, and we can, on the basis of those characteristics, we can differentiate between different rivers as well, and from the different sections of the river as well. Okay, it is echoing. Is there any problem?
Say again.
Okay, so basically, what happens is that uh, the sand, where the sand comes from? The sand comes from the water that has been washed down from the glacier itself, right? It brings the boulders, rocks to with it. The rocks and the boulders get crushed within themselves, and that makes the sand, right? And that sand was deposited onto the floodplains. What are the floodplains? The floodplains is something which is the river width, right? The area that is covered in the river width. The sand is get deposited on the river side as well. So if you go into any kind of river, exposed river, which is not human, like if you go into any kind of river, you can have a something which is a soft, um, soft area, right? You stay there, you can understand the soft area from the hard rock area, right? So that is where the sand gets deposited, right? So that why it is the mining happening, the sand, that is sand mining happening. So the topic focuses on the understanding of the how sand extraction activities are altering the physical shape of the river, right? The morphology, which is the specific stretch or specific term of the characteristics of the river, right? So why it matters, the sand, why the sand matters? Because sand is far more critical or far more essential for us that we thought. Because we say sand, and we say why why it is important for us. Well, the we cannot use, okay, so let me little bit go into the depth of why it is important, right? So the sand, that is essential, right? But why? Because the reason is that the sand is essential because we use this sand to make our infrastructure, silicons, which is used in the in making of chips, or glass works, or some other kind of infrastructure works, right? So it is pretty much needed to have a growing economy. Because if you can't build a building, you cannot do something on those things, right? You cannot do everything into the open field, right? So if you wanted to get a good quality silicon, you have to have good quality sand, and good quality sand comes from the river. So it's just that uh, sand is the second most uh, like needed, or the second most critical element after water in our planet, right? It is estimated that 40 to 50 billion tons of sand is needed, and it's mined everywhere in the world. But the river which brings the sand, it is around like 10 to 20 billion tons, right? It's 19 billion tons to be exact. And especially in the countries like us, or the growing economy countries, it is really really important that the sand uh, will be going to further be a be a you know, be a part of the growing economy, right? So so and why is the mining of the sand is impacting the morphology? That is something that is uh, I try to understand in the research, right? So basically, what happens is that if you mine the sand, right, it's okay. But mining creates a problem. Mining creates something called a pit, and that pit can be can lead into turbulence in the river. The sediment deposition, the sediment which is the sand deposition, can be can be altered by the activities. And excessive sand mining can really really deplete the surrounding groundwater, which is your well water, which you pump through your hand pumps and all those things. So the groundwater depletes because of the sand mining, because sand holds the uh, river, right? So it's a barrier for the river. And well, that mining, unsustainable sand mining, can degrade the river ecosystem. Because uh, if you mine the sand from the river bed, which is the bed of the river, which is the deepest point of the river, right? So uh, that in that way it is affecting the ecosystem, affects the groundwater. Riverbed can be incised, which creates turbulence, which I have talked about, and linked to the bank instability. And that what is happening? is that if you really have a greater length of sand mining, the surrounding soil gets eroded by the river itself when the flood happens. And there are plenty of cases in everywhere in the India where when flood happens, the people's home or the people's lives is affected by this sand mining. Okay. And that leads to the bank instability and collapses and worsen flooding, and even damages infrastructure like bridges. So what happens is that when the pit happens in the middle of the sand, it propagates. And what so the bridge has their pillars into the sand, into the riverbed, right? And if the pit propagates, there is a process where the pit propagates and it goes right into the under of the uh, bridge pillar. It will get collapsed, right? There is a case in the Maharashtra itself that the bridge collapsed for the illegal sand mining because of the pit was created. uh, so these are the things that are major concerns of illegal sand mining. The environmental assessment department has made some pretty good distinctions of how much sand that you can uh, mine. But people, the need of sand is such that the people still mines from those places every day, in and out. So yeah, so that is the problem that we are facing, and that's why I guess that it is much more interesting to look upon up to the um, research or the topic. It is interesting to understand that why it's happening, how it is happening, and where it is happening. So these are the three questions that I tried to answer, uh, and how well we can address these problems or detect these problems. And that's where the AIML part is also comes to the.
Yeah, so about your research, so can you tell us about the AIML process and the AIML workflow that you have used it? Can you help us go through that process, like how you did? So you told us you have collected the data from the satellites, and you have mentioned, you have said that how you have filtered out the images and how you have chosen it. Can you tell us about the process, like which models you have used and how you have used the AIML techniques in your research?
Hmm. Okay, so the process that I have used, right? So, um, well, it's a simple process. In my study, I haven't have done some novel, making a novel algorithm, because it takes time to make a novel algorithm. It is not a 5 or 6 months play. I mean, my geniuses can do that, but I'm not that genius. So, so uh, it's not that I have done some novel algorithm, making novel algorithm, and so on and so forth. I used which is available, which is, and to be honest, it is not required to make a novel algorithm for my study. I think for my study at that time, uh, and that's why I used the simple machine learning algorithms, which is k-means clustering. So machine learning algorithms can be divided into regressional based analysis and the clustering based analysis, right? And I needed the clustering based analysis because that is what I'm, yeah, that is what I'm trying to do. And k-means clustering, uh, sorry.
Yeah, because it was unsupervised, right? You didn't have the label data.
Yes, that I'm gonna come. That I'm gonna come. Just wait. So the k-means clustering is unsupervised clustering. Absolutely, you are right. Why used unsupervised clustering? Because it is the supervised clustering. It takes time to train your data and then to test your data. It is it is little bit time consuming in that sense. Okay, so you have to. So basically, what happens is that, okay, so labeling tabular data. Tabular data means Excel data or something like that. Labeling that is quite easy because you just keep filtering out that what you wanted to change. You filter that out, you change the data, or you label the data as a trace or train, and then you you put it into the machine learning algorithm, and then it can really learn, right? But for us, for a spatial data set, like satellite data set, which is an image, you have to go into you have to zoom it, you have to go into the nitty-bitty detail of that image, and then you have to label it as a trained data or test data, which is a very time consuming process. I believe me, when I started I started using a supervised classification. Then then some of my senior lab mates has told me that it would be advisable to use unsupervised classification to see that is there any changes happening. And why unsupervised? Because it gives you the ability to understand that in different scenarios how unsupervised classification will simplify the workflow of the whole system, as well as uh, how complete or how accurate it can give you the desired results. So there is that. So that's why I used k-means classification. But there are other clustering or classification based algorithm is out there, XGBoost or something like the DBscan or something like that. You can use that, and people has used that after I done my work, and then I have seen some papers which has really used that and done different type of works by detection in the detection and classification fields. So yeah. And what k-means algorithms do? Well, for your audience, the k-means algorithm automatically group the pixels of the satellite into different clusters based on their spectral signature. What is spectral signature? The spectral signature is the amount of the you said the bandwidth, right? So the light has a different bandwidth or different spectral bandwidth, right? And the when sunlight comes into different type of objects, it reflects different type of bandwidth, right? And the satellite, what happens is the satellite detects that different type of bandwidth, and based on the bandwidth itself, they do the classification. The algorithm, the k-means clustering algorithm does the classification. And initially we set to create 18 clusters, and comparing to the false color composite images, we false color composite, which is a what is a false color composite? False color composite basically is the uh, using a negative image. Okay, so have you seen the negative image of an image? If you have used an old photograph or old film photograph, you have seen some negative images, right? So false color composite is like similar thing. So, and then we used to create 18 clusters, and from that 18 clusters we chose 4 or 5 characteristics, and then we do the reclassification. So this is another technique of reclassification, right? The classification is done by the unsupervised classification. Then the human intervention part is there, from the reclassification. Then reclassification has been done, and then we use the data to analyze that what is happening and what is not happening. So in that way, it is little bit streamlined. It is little bit less time consuming, but you can make a system where you ingest the satellite images, it will give out the result. In that way it is a simpler process, and you can have a supervised classification or unsupervised classification, but the supervised classification will have to have the training data set on. And there is a major problem with that, because every day the sun is not in the same direction, the earth is moving, right? So the sun's tilt angle is also different, and the satellite is not in the same position to take the picture like it did in the last time. That's why even if you do this training data set, and then going to the testing data set, and you have the same and the model is ready, you took that, you test it, okay, you have a good result on the Yamuna river, you took that model, you put it on the Ganga river, it will not give you any kind of good result. There is an ongoing limitation of using satellite images, as well as using machine learning, sophisticated machine learning algorithms, to be used in the field of geology or field of other environmental sciences. So there's that. So we have also talked about the limitations as well in the question itself. So yeah, so there's that, and then we also perform the accuracy assessment, which is a which is like F1 and some other accuracy assessment techniques, right? It is pretty much done in the any other AI classification. Yes, 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 yes. Those are the things, uh, and it showed that the classification worked really well. The cloud cover also creates some challenges, because if the cloud is covered, then you cannot see through the clouds, right? The light will be bounced off the clouds itself, or the you can only see the um, clouds. So you cannot see what is happening there, and that's why there are different approaches of the satellite data set that can be used, which is SAR, which is a synthetic aperture radar, which is a radar data set, right? If you have heard of SAR or synthetic aperture radar, we will not go into the synthetic aperture radar. What is a synthetic aperture radar or not? But that radar data set pushed through the cloud, it can give you the any day all weather monitoring, or any day and night all weather monitoring, because it has its own illumination. Illumination means the own source of energy, and the detector, right? So in that way, it is much more sophisticated, and the data is also sophisticated. So yeah, you can use those things as well.
So I have two questions. First is the K-means clustering plays a major role in your research, right? And my second question is,
Yeah.
before you gotten into research, were you ever been exposed to the machine learning or any programming, or just after when you started your research, you have started learning about machine learning and coding? And while you were learning that, were you given a supervisor who was expert in machine learning, or did you learn it all by yourself?
Okay. So, well, the first question, right? Have I ever exposed to the machine learning? Well, I might have, because in the physics they are using machine learning techniques and all. They are always talking about machine learning techniques and all. The physics and the computer science people are also in that point. I guess in 2020 the ChatGPT has also come, right? Maybe not 2020,
2022
2022,
or November
2021,
2022.
2022. Yeah, the ChatGPT, yeah, the ChatGPT really came, right? So machine learning is there. At the time, the ChatGPT is not. It's much more sophisticated in like last 2 3 years, right? But to be honest, I did know about machine learning, but it seems much more, much more have computer science heavy. I It seems to me at that time, but when I started understanding it, started implementing it, and I didn't have to write my own K-means classification code. It's just that I have used some libraries. So some libraries, some scikit-learn libraries, or some other libraries. Like what I used particularly, or that I can say, is that uh, do you know Google Earth Engine,
Yes.
which is a platform provided by Google to do some special analysis, like the satellite data analysis and so on and so forth. So they have their own libraries called Weka, and so I used K-means classification on the Weka, and yeah, I have done my analysis and all. I try to understand, and I understand something pretty much, but I don't didn't give into the detailed math of the why K-means clustering is also working or not. But yeah, I did try to understand. My supervisor works in the field of remote sensing, tribal gemology, machine learning, so interdisciplinary research. He had helped me. My lab mates also have helped me. Lab mates means the senior lab mates also helped me. So they are also using some kind of machine learning techniques in their own research, and they have helped me a lot. So yeah, in that way, I was guided by through the supervisor and through the lab mates. So yeah.
And when you mentioned that you didn't implement the K-means clustering by yourself, and you mentioned the library name skeleton, right? So I would like to add to that, like even 99% of the data scientists out there don't even implement any algorithm by themselves. Everyone uses the library in framework available to them anyway. No one gonna hard coded it any algorithm by themselves.
Yeah. So to answer that question, right?
It would.
Let me let me let me try to answer this in a way which would be understanding for both of the cases, right? So hard coding an algorithm which is primarily available in any kind of library form, it is not necessary. It is not. I mean, it's like, why you do such thing when you have some libraries, right? When the libraries are available, right? But if you wanted to create a novel algorithm, if you wanted to create a novel understanding, novel research, then you have to hard code it. Then you might not use k-means. You might use some form of k-means or some form of XGBoost or DBScan, which is a classification based algorithm, but you will use it in a different way. The parameters will be different. How the model works it would be different. So in that way, people in the geological science does not geological science. I mean, people in the earth and environmental science does hard code and does use the library at the same time. It's based on the project or the based on the research that they are doing and what is needed, right there and there. Uh, so people will gonna hard code because, okay, let me tell you one example. If you wanted to understand the crop health, right, you have to hard code. There are specific type of crop health problems which you, if you want to understand, then you have to hard code the algorithm itself, from the detection to the prediction, from the classification to the analysis. You have to hard code itself. But if you are doing something which is taking publicly available data sets and trying to just classify it to showcase some other aspects of the data or other characteristics of the data, you will use k-means or dbscan or some other supervised or semi-supervised classification learning techniques or like that. So there is no hard and fast rule, or there is no hard and fast saying that people either use libraries or either use hard code. So it is based on what is needed to do. So there's that. And every other science, let's not talk about earth and environmental science, but every other science, people are using uh, pre-made libraries, especially in Python, not in C++. I mean, C++ is much more faster, or C is much more faster to implement. C++ especially is much more faster to implement in the machine learning. We know that, but people are using Python libraries because it is available. It is abundantly available, and there are much more sophisticated libraries in that way, like TensorFlow or PyTorch or scikit-learn or Keras, and people are using that. And Google Earth Engine is a JavaScript based platform, so they are using Weka, which is a JavaScript based platform. So yeah, so people are using that. There's that.
So, about your research, like, are you still working on it, or are you looking forward to working on it, or is there more to your research after this?
Well, no. I mean, I wanted to touch upon this project, which is, and I did, but I wanted to do work in the field of remote sensing, as well as in the some other kind of data sets and machine learning techniques as well. I wanted to create some novel machine learning techniques, and I'm trying to do that. I will be trying to do that in my future research projects. But I don't know. I mean, I have to see which suits me, which interests me better. So yeah, so there's that.
So, can you tell me the previous similar work that's have been done in the field of Earth observation? about the future recent development in this field.
Hmm. 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 Okay. So basically, okay, my work, which is definitely built upon the significant body of previous research. Obviously, some of the notable names who had done the work in the fluvial geomorphology is by Professor Rajiv Sinha, who is a current faculty in IIT Kanpur, and some other like friend, Dr. Friend, Dr. Professor Sinha, and some other people as well who have done the preliminary work in the field of fluvial morphology and all to understand these things, to understand the river systems, right? And then uh, like going it's a decade long research more than a decade long research. It started around 95, 93, and it is still ongoing. Even when I done my thesis, Professor Rajiv Sinha is still working on some has worked on some fluvial morphological paper using UAV or like drone based system, right? So, and trying to understand more characteristics of sand deposition and sand degradations, right? So it helped me a lot. So yeah, and uh, in China there are some studies has been done. There are some other studies, like there are many more studies has been done in the previous, which deals upon with the earth observation. The earth observation primarily preliminary started, I don't know when it explicitly started, but in through the Lancet program, it has been a real good uh, motivator to in the field of earth observation. I can say that, and recent advancement in various kinds of satellite programs or satellite observational programs, which monitors our health and not our health, our planet's health, monitor our planet's health and the dynamics. That is in that way it is ongoing research, and it's still giving us novel novel ideas and novel theories how earth is really working. So yeah.
So, how often does the field of AI/ML has been used in the field of earth and environmental science in general?
Okay, so AI machine learning are becoming increasingly pervasive, I can say, in the earth and environmental sciences. So it's really exploded in the recent years, obviously, driven by the massive amounts of data that is generated by satellites and other instruments, like seismological instruments. Do you know that? Okay, do you know there is a something called Raspberry Pi?
Yes, sir.
You should know that. Obviously, you will know. Yeah. So Raspberry Pi is using to measure seismic activities, and it is connected through a single connection which records the data, and people can see that data and understood that what is happening on anywhere around the earth seismologically. So there is a massive data set that is happening. There are arrays of sensors that has been put to understand the how the earth is like either it is cramped up and going upwards, or it is just pushing away and then going sublimated, right? So in that way, the how the earth is changing, you can understand through the arrays of uh, network, the sensors that has been put into the soil. And to be honest, there is a one thing that I have done called seismological workshop, where I understood and I saw that. Have you heard about the 2015 Nepal earthquake?
Yes.
Also, obviously, everyone knows about that. The 2015 Nepal earthquake, which is a massive earthquake that has happened in the Nepal. The Nepal the portion of Nepal has been lifted to 7-meter high from its initial point. So there are some portions in the Nepal which is cramped up and pushed up through the seismological event. So how do you know that? Because of those sensors and those Raspberry Pi seismological detectors. So in that way, there are massive amount of data that is generating right now, and more data means more information. More information means you can feed into more sophisticated machine learning algorithms or machine, and then you can understand what is happening out there. So yeah, in that way, machine learning or the complex simulation, sensor networks, satellites are really exploded in the recent years, and that's why the machine learning also exploded in the field of earth and environmental science in the recent years. And in like I said that in my like I have used machine learning in my own thesis for classification. It's a fairly common application in the field. And in climate science, okay, so come up to the climate science, right? Climate science, like improving model prediction for any kind of climate prediction, it is going to have a massive kind of a scale which is around more than around 100 kilometers. But what is happening on the on so 100 kilometers means 100 kilometer by 100 kilometers square, right? So so where you live right now, if you really go 50 kilometer right, 50 kilometer left, 50 kilometer north, 50 kilometers south, you will have a 100-kilometer area. But that is a massive area to understand what is happening in your own locality, what is hyper local climate is changing. How are you gonna understood that? We're gonna understood by using machine learning. So to scale down the climate studies, we are using machine learning algorithms as well. um, for weather forecasting, right? So in oceanography, cryospheric science, cryosphere means glaciers. Cryosphere means the glaciers and the polar regions, right? How the polar regions is changing, because you cannot go into the remote places of the polar regions, the remote places of the glaciers, right? You have to see through the satellite. And how you're gonna change detect the change? It's the same as the classification that I have done, and you can see the change in the cryosphere itself. So yeah, there's that. And mm, then hydrology, like how hydrological mapping has been done. So groundwater depletion and all those things that I have talked about, which is also been understood by some various kinds of machine learning techniques and other algorithms as well, made for hydrology and all those applications. So yeah, so there's that. uh, I have talked about seismology because seismic activities is also happening, and it is important to talk about that seismic activities. Recent Indonesia's seismic activity which has happened, uh, people realize that these are the areas that has been affected more than other areas, and so they can put the resources into where it is needed rather than where it is not less needed, right? Put it that way. So yeah, so in that way machine learning is helping in the earth and environmental science field in the recent year in many more ways, which I haven't talked about, which I can't talk about because I don't know all of the machine learning research that is happening around in earth. But yeah, it is fascinating that machine learning has a very big effect in the field of earth and environmental sciences.
So tell me, during your research, when you just get your hands into the machine learning, when you are exploring more of it, when you are learning about it, and when you were trying to see the practical use of machine learning in other research of geology, when you are reading other work in the field of machine learning, can you tell how often you have come across machine learning in the field of geology research, and how does it benefit the field of geology, and where the machine learning is lacking behind in the field of geology? What are some problem statement in the geology that machine learning still have limitation to solve it, and what's the most uh, research area in the geology that it's being benefited most by the machine learning?
So likewise, I talked about, right. So where the machine learning has been a pretty good advantage for the field of earth and analysis. Let's talk about the where it is lacking behind. Well, machine learning is like a black box. Everyone knows that. Even people are trying to understand what is happening in the black box, and the preliminary some kind of I have seen some preliminary research and the result that is circulating on the LinkedIn itself, that what is exactly happening on the machine learning black box has been understood, right. So black box does not tell you how or why it is happening. It tells what will happen. So it predicts the future, but it doesn't tell you how or why, right? Why it is happening or how it is happening. So in that way, it is a limiting factor. Machine learning often leads large, high quality data sets, like I said, which aren't always available because you cannot put sensors all over the place in the planet, right? You cannot do all over the planet like in one go. You cannot observe all the earth in one go, right? You have to. Then if there is something has happened, you will only understand when it's happened. So the future prediction is still lacking, and the why and how is still lacking. So that's the point. And historical data is not there. So if you wanted to train your machine learning, then you have to have some kind of historical data set, right? Then if the historical data set is not there, then how are you going to train that? How are you going to test that? So there is that problem as well. And yeah, so these are the some of the ongoing discussions around the computational costs, ethical considerations, and all those things. To and that limits the machine learning processes in the earth and environmental sciences. Although it would be sufficient to say that right now the amount of data that is generating, it will help for the future machine learning algorithms, the future systems, to use this historical data to understand the future, to understand and predict the future part, right? So in that way, it will help, but not right now. There are some limitations using the machine learning itself.
Yeah, because it was because of the lack of data, right? Because they say data is the fuel for machine learning. Without data, it's the model
Hmm,
won't run
hmm,
on anything. So
hmm,
where there's
hmm.
lack of data, we can't apply the techniques of machine learning. Right?
Hmm, hmm. No, it's like that. Okay.
Yeah, so, like after machine learning got into the research field of Earth and environmental science, did it help researchers and scientists to find some breakthrough or find some hidden pattern or find or help the researcher who were stuck on that particular research since longer amount of time? So did machine learning help after it get into this field of research in the geology?
Yes, yes, yes. Well, machine learning has enabled progress in the areas that has been previously stuck. So basically, acquiring data, right, and understanding how that change is happening. So the data volume or the data complexity, like how characteristics of a system is related to the other characteristics of the system, right? So let's say we talk about the river system. So the sediment deposition is happening. Why mining creates a pit? Why pit travels to the upfront? Why the pit creates something called the incision in the floodplain itself? So understanding that, it is evident that to understand to the volume of the data, not only the volume, the complexity of the data. In the climate science, every other thing is related with the every other thing. It's a continuous dynamic process, right? And to understand the complexity, that what is the percentage of the you know the, how can I say, what is the percentage of the um, effect that is happening in a model. So let's say you are predicting a model. There are some parameters that you set. What percentage the contribution of that parameter in that into that model. How are you going to understand that complexity, right? And if it's not about two or three characteristics, it's about lots more and more complex systems, right? The climate itself is a complex system. So understanding the complexity with the volume of data, the machine learning is needed. uh, Predicting river flow, where it's gonna predict, when it's gonna flow, where it's gonna not gonna flow, or paleoclimate, or some like previously what has happened in the area, how it formed, to understand those things, right? So yeah, so the speed of mapping dynamic features like glacial retreat, wildfire spreading, has increased dramatically thanks to the machine learning process. And image analysis, which is, you have a video about YOLO, right? You only look once, which can also be used to understand wildfire. So it's also help uncover subtle relationships and complex relationships. So the climate, not only climate data but also the ecological data, right? What is happening in a lake, how the fish are going to be affected by the plant that is planted right beside the lake. There is a complex system, and you have, if you understood that, you're gonna have to comprehend the complexity of a lake ecosystem, right? So yeah, or the forest ecosystem, how every other part of the forest, or every other uh, mm, characters of the forest, right? The small shrubs or the big trees, how it affects the overall climate of the forest, or how the forest overall affect the climate of the earth itself. So these are the complex systems. So you have to understand that. Biodiversity monitoring, like identify various types of species. Are they great or less? Um, Processing data volumes, like we have talked about, right? So it excels finding the non-linear patterns in complex high dimensional datasets, which characterize the many earth systems. And that way, machine learning helps understanding the our precious planet, and not only that, but also to find uh, breakthroughs on that. So yeah, in that way it is helping a lot. So yeah.
Okay, so here's my last question about this, and it will be the question that's
Yeah.
like the trendiest, and everyone, the question that makes everyone anxious and in every single field. So the question is like, will AI replace
Yeah.
geologist or the researcher in earth and environmental science?
mm, mm. Well, okay. um yeah, it's an ongoing topic, which is happening in every day, where I when I open my LinkedIn, or any other website, the people are going to talk about, is AI replacing humans in every other field. um, and there are some speculations that ChatGPT has made some PhD level agents that can do PhD level science, in physics at least, and it will replace the PhD scholars from the lab itself. And so there are speculations, but where do we draw the line? Well, to be honest, and talking from my perspective, from my understanding, it will not replace the human brain, because human has created AI, right? Or machine learning or something like as whatever human has created. Computer aided humans. Human has created machine learning or artificial intelligence. It is aiding into human knowledge, and this is the process. Human has made bronze tools, or to hunt down the bigger animals, to cultivate other foods. So it's always a, so there is a saying in science, like necessity is the mother of invention, right? So there is a necessity of having highly sophisticated systems that can understand our problems and can show a path of better understanding, and AI is doing that. That's it. AI is going to replace some boring repetitive tasks. If you are doing some boring and repetitive tasks, AI is gonna help you that, so that you can really put your brain and your thinking to create meaningful things. And in that way, science is going to have a vast help from the AI. So AI is a powerful tool, obviously. It's an amplifier of our capabilities, right? uh, but it does not replace the core skill of the geologist. If it cannot go into the field, and you know, if it doesn't, if it not connected to the internet, or if it doesn't have the right system, it will not have the thinking power to put out a pen and paper and then draw the whole thing, or have the whole understanding of it and make a document out of it, right? So there's that. And uh, AI is excellent in processing vastly complex systems, complex volume of data, but augmenting the geologists and making them obsolete, uh, I don't think so. Yeah, it can help augmenting, but it will not making them obsolete. And it will not certainly make any of the scientists or researchers obsolete. It is just going to help that. And that's why we have a Nobel Prize in AI, and that's why we have a Nobel Prize in biochemistry, uh, because people has used AI. So yeah, we just have to think that it is not been used to replace complex tasks which still needs nuances. If people think that AI can still understand nuances, it is not. You have to reiterate to get your desired answer still from the chatbot itself. And I have used all of the chatbots that is available, right? From the major companies like uh, Google, ChatGPT, uh, X, which is a Grok, Perplexity, or
Claude.
Claude, or something, some similar. Yeah. So they still don't understand the nuances. They still don't understand what exactly you are trying to find, or what exactly you are trying to get answers from them. And people are saying that it is going to disrupt education and all. Yeah, I mean, there is a very good video by Veritasium, uh, which shows that there are a lot of speculations from the CD to the calculators to the scientific calculators that it will disrupt the education system and something so and so forth. But it is not. So AI will not also replace or disrupt education, but it is going to certainly going to be a major part of the education. Just like we are using computers and mobile phones or digital tools to understand our information. And because it's pretty much dynamic, it's ever changing. It is as evolving as us. We have evolved much more sophisticated way, and AI is also having that same thing. So yeah, but no, it will not certainly replace geologists. It will not certainly replace people who are thinkers, who are researchers. As of now, I don't know the future that holds, but still, as of now, that I what I understood is that the no, it will not going to replace. Rather, it will give us the tools that will help us to understand what we really want to understand much more. So yeah.
To that, I would like to add that the reason is because AI is good at following the instruction, but it's not creative. It can't think of out of box solution, and it can't implement something that doesn't exist in the internet. Like you said, like if you disconnect it from the internet, then it won't be able to think of its own. So that's where AI lacks. It only follows the instruction, and it only gives the mixed up output which is already available in the data. But when it's come up with something new, then that's something where it will be like. And that's the reason that humans still have lots of maybe decades or centuries to go until it replaced them.
Yes, yes, yes. Yeah, so I would like to touch upon a little bit more nuance on that. There are certain models that has been developed to think or mimic like a thinking of a human. They are good. They are good, right? But they are not that level of good. But yeah, I mean, if people really try to understand what is happening or what is the problem, uh, those thinking models, let's say that thinking models, will definitely give us some answers. There are some research ongoing which says that which really shows that there are various different kind of permutations combinations that you can have by when creating some major discoveries, right? But but you have to come up with a question. It will not question itself to give your answers. The question part is still on your side, so you can still ask questions. So the power is still lies with us. So yeah, in that way thinking models do help. They are way more sophisticated than any other chatbots, like any other normal chatbot models or LLMs. But thinking models which mimics the human brain, it just helps. It's a tool, and people have to believe on that. And if you're doing a boring or immediate task, yes, it is going to be replaced by AI because it is much more efficient, as it is as using machines on factories is efficient rather than human labor. So it's just like that. So the industrial revolution is happened because people are going to use machines rather than human labor. This is the same thing that is happening in the software side right now with AI, because the boring and repetitive task is going to be replaced by AI, and no one can stop that revolution. So it's pretty much, I mean, it's pretty much done right now. I don't know. It's pretty much done. So yeah.
All right. So we will end our discussion on AI. So let's move on to the question for a younger generation, especially for school students. Let's say if a student who want to pursue their career in geology, want to build their future in geology, how will they know if this field is for them? How will they know if I should pursue my career in geology, if I will succeed in geology, like do they need to be good in mathematics or science, or do they just need to have some passion or excitement or curiosity? Do they just need to be dedicated? Who is this field especially for, and how would the younger generation know if they should pursue their career in it?
Hmm. uh, I always ask any children when I meet them is, do you love the planet Earth? Do you love the dogs that you love, the cats that you love, the birds that you love, the flowers that you love, or that you see, the trees that you see on the road, or the rivers, the mountains that you went on vacations to see that, right? Do you love them? If they say yes, then I say, then the field of earth and environmental science is for you. It's not only to observe but also to understand our planet. So if you are interested in understanding our planet, why is that? Why our planet? I mean, why our planet means why our planet has happened, how it's happened, and how the dynamic processes changing the planet will affect our generation. Not only our generation, because we are the biggest, one of the biggest species on the planet of the earth, right? The uh, ants are the similar kinds of uh, species that is right now residing on the earth. So why dinosaurs formed, why they are wiped out, why they are extinct, or how they are extinct, and what is, and have you seen the movie Ice Age? it's an it's
I
an
heard of
it's
it.
an actual, yeah, it's an actual event that has happened. why earthquake happens, why storms happen, why rain happens, and why you feel warm, why you feel cold, what is the reason behind it, why you feel wind. So if you really wanted to have an answer, the field of geology or the field of earth and environmental sciences yours. And one should pursue, if you really want to understand those things, uh, even if you're not, try to understand it from the outside. If you are not in the in any course, or you don't want to understand, but people should understand that the planet is changing. The planet is changing through human interventions mostly, and also to the changes in the nature. It is a human induced change, obviously. I am a pro climate change uh, public, so yeah, or person. So if people say that no, there is no climate change is happening, I would say that is a very very wrong thing that you can say. Because if you really understand the earth, or you want to understand the earth, then you will really understand that the the climate is warming up, and it will be a greater interest for our future generations to really uh, understand about the uh, process that is happening. So yeah, in that sense, I can say that people who wanted to understand the earth, the field is theirs. So yeah,
But how would we make the younger generation gain the enthusiasm in the field? Because I'm sure the school system have failed many
yeah,
younger
to
potential scientists.
yeah, understood. Yeah. So basically, as a researcher, or as a uh, so if you are having some kind of degree in earth science, let just not put it as a degree on your drawer or on your wall itself, right? Put that uh, put that knowledge uh, into teaching childs, or the teenagers, or the students, that what is exactly happening with our planet. If people will be aware of those informations, then people will be interested. How people is interested in the field of maths? Because they are exposed to it. In that way, students have to be exposed to the field of earth and environmental science to get interested on, and to have a much more robust kind of community in everywhere on the planet earth, to have a not only have a career on this field, but also to be interested on this field, and the young, and to be and getting interested in the from the younger generations. So yeah.
So, what advice will you give to the person beginner in the geology? Is there any mistake that you have made earlier in your career that you want others to avoid? That they don't waste their time on this and just do the smart work, just maybe follow some kind of shortcut and don't spend or get stuck on some
No.
specific amount of task or something like that.
Okay, so no. Well, I don't think that I have done that kind of mistake, but um, people who are interested in the field of geology, who have taken the field of geology, uh, they have to understand that the field of geology is not about the structural geology or the geochemistry. These are the main part, or the petrology, like the study of rocks and all. But or the finding of oil, something like that. It is not that, right? Or become a civil engineer in that sense, right? So yeah, it's not that. It's not that. Uh, but to question, try to develop the ability to question, to understand and question, and in that way. I believe that I have done some mistakes on that, but everyone is going to mistakes. Everyone is going to make some mistakes in their life. Even if I say that don't make this mistake, people will go. We will make these mistakes. So I am not in a place where I can give or give any advice or say anything that don't make these mistakes, because people who says that don't make these mistakes has done some mistakes. So I'm just going to say that I have done some mistakes, uh, where I should have understood that how to question much more effective way. My supervisors always told us that don't ask questions to for the sake of asking questions, right? Understood what you're trying to understand, uh, and then ask questions and try to uh, get the skill of asking questions, like have the skill of asking questions, right? And that way it will be much more helpful, not only for you if you're going to get a job or any kind of other uh, companies, oil companies or something like that, but also in the field of research as well, because you will ask questions, and uh, and that is what research means: ask questions and try to find the answers for yourself. So yeah.
All right, Sohan. So it was amazing to have this conversation with you. It was. I'm really glad that you were my
Thank
first
you.
guest, and you really shared some amazing insight. Is there any ending remark that you would like to share to the audience?
Well, I am glad. It's like really late at night, but I am really glad that I am a part of a part of a podcast that I really love listening to podcasts. Some very good podcasts. I don't often listen to all of them, but when I do, I really try to find some interesting topics that is happening. So yeah, in that way, uh, I am very glad that you have started this podcast, not only to bring people like me, but also like from your community, from the computer science background and all, but also to the from the different science communities who has been a part of this journey. And yeah, I would be much more happy to be a part in the future episode as well, if you have the like if you do some if I and I would definitely try to share like some of my works or some of my work that I've done in the future, and much more information, more in-depth topics as well, if I really wanted to, if the people wanted to listen to me as well. So yeah.
Definitely,
uh,
after listening to this episode, I'm sure people will love to listen more from you, and I would really love to have you on another episode in the future. It was a really great talk and really share great knowledge in your field. Yeah, so that's it, audience. I hope you love the podcast and thank you if you have stayed tuned till now, even though it was so long. And if you love the episode, I hope you subscribe because more researcher and more PhD scholars gonna come. So I hope you love the channel, subscribe, and thank you. Stay tuned. Have a good day, everyone.